All right, so we have um, a system of equations where we have a quadratic and a linear. So this is similar to what you did last year in math. You solved linear systems. So now we're mixing linear systems and quadratic systems together. Um, you can actually solve any kind of system. Um, can you solve them all algebraically? Can you manipulate the equations to isolate variables? Actually, there are some that you cannot, so you have to use graphing. Desmos is a great tool. I want to look at how would we do this without Desmos, and then I'll show you during class using Desmos. It's way quicker and easier, but we need to know the algebra. So I have y equals this part of the system and y equals this. So basically what it means to be part of a system is if I can manipulate this equation, maybe isolate for a variable, I can substitute the expression in wherever I see it into the other equation. Like for instance, you would never do this, but I could take this equation here, this bottom equation, and solve for x, and then plug that result in everywhere that I see an x. That's actually a lot more work because there's a lot of x's and I've got squaring to do and distributing, and I'll have fractions. Bad idea. In fact, it's easier since I know that y is equal to 8x plus 3. Everywhere I see a y, and I see a y right here, everywhere I see a y, I can put 8x plus 3 because 8x plus 3 equals y. They're equivalent. So I can substitute it. That idea is called substitution. You could also use linear combinations here and cancel out variables, but this is all set up for substitution. So in place of this y, I'm going to put 8x plus 3. So I have 8x plus 3 must equal this, negative 2x squared plus 4x plus 1. All right, and now I have a quadratic equation. How do we solve a quadratic equation? Get all the x's on one side. Try to factor it if you can. If you can't factor it, then we'll use quadratic formula. I'm hoping we can factor it. So I'm going to add two, since I like my x squared. Since I like my x squareds to be positive, I'm going to get everything to the left side. So I'm going to get rid of it on the right side. So I'm going to add 2x squareds to both sides. So plus 2x squareds. I'm going to subtract 4x. I want this side of the equation to equal 0. That's why I'm getting rid of each of these. So I'm going to minus 4x. And then I'm going to minus 1, and I'll minus 1. And so I'll be left with 2x squared. 8x's minus 4x's is 4x's. And then a positive 3 and a negative 1 combined to 2 equals 0. One of the things I notice about this is that they're each coefficient is a multiple of 2. So I'm going to divide both sides by 2. And I'm dividing 2 into each of these terms. So I get x squared plus 2x plus 1 equals 0. And now I have to solve this quadratic equation. Does it factor? It actually does. Looks like it's x plus 1 squared. How did I get that? Well, I know I need two numbers that multiply together to give me positive 1. So I know they're either both positive, they're both negative. There's not a whole lot of ways to multiply together to get 1 if you're talking about integers. And then they have to add up to 2. So the two numbers that multiply together to give me 1, positive 1 and positive 1, combined to give me 2. So I know it's x plus 1 equals 0. And so I guess negative 1, x equals negative 1 is a solution twice. So we call that a double root or a double zero. It'll graphically, that'll show up as a bounce on the x-axis, but here we're not just graphing the parabola. So now I know the x value where those two graphs cross, where the x coordinate of the system, of the solution to the system. So now I need to find the y coordinate. Now I could plug in x equals 1 up here. Not too hard for us to do. It's negative 2 times 1 squared is negative 2 plus 4 plus 1. Or I could plug it in here. Why not just plug it in here? Right? There's less work to do. So 8 times negative 1. 8 times negative 1 plus 3. Looks like it's going to be negative 8 plus 3 is negative 5. So when x is negative 1, y is negative 5. And that is the one point that appears on this graph and on this graph. That's what it means to be a solution. It's a point or many points that are shared by all of the equations, or it could even be inequalities. But here we're looking at equations, so it's the point or points that appear on both graphs. Okay, there you go. Desmos makes this way easier.